Every project, no matter how meticulously planned, exists within an unpredictable universe. Deadlines slip, costs fluctuate, stakeholders change priorities, and unforeseen risks emerge at the worst possible moments. Yet, amidst all this uncertainty, one tool offers clarity: probability. In project management, probability is the bridge between what we know and what we can only estimate. It transforms vague uncertainty into quantifiable insight, turning risk into measurable strategy. When used correctly, probability doesn't just describe the chances of success or failure. It empowers project leaders to make informed choices, set realistic expectations, and optimize resources with mathematical confidence. From risk modeling and probabilistic scheduling to Monte Carlo simulations and Bayesian analysis, probability provides the foundation for evidence-based decision-making. It allows managers to stop relying on instinct alone and start building plans rooted in data, logic, and likelihood. In this video, we'll explore how probability weaves through every layer of project management, from cost forecasting to risk assessment, from task estimation to portfolio strategy, revealing why the most successful project managers don't fear uncertainty. They measure it, manage it, and master it. What is probability in a project context? In simple terms, probability is the measure of how likely an event is to occur. In project management, these events are potential outcomes, both positive opportunities and negative risks. A probability of 0 means the event is impossible. A probability of 1 means it's certain. But most project scenarios fall somewhere in between. This probabilistic mindset helps project managers accept that certainty is rare and that planning should revolve around likelihoods, not absolutes. By adopting probability-based thinking, teams learn to anticipate variations in outcomes instead of being surprised by them. The marriage between probability and risk management. At the heart of project management lies risk management, and probability is its language. Every identified risk is assessed based on two elements: probability, likelihood, how likely is it to occur; impact, consequence, if it happens, how severe will it be. The combination of these two gives rise to the risk exposure, often visualized in a probability impact matrix, PIM. For example, a risk with a high probability, 80%, and high impact, costing $1 million, deserves immediate mitigation. A low probability, low impact risk might just be logged and monitored. By quantifying probability, managers can prioritize mitigation and allocate resources where they matter most. This scientific approach moves risk management from gut feeling to statistical reasoning. Beyond the basics, the Monte Carlo simulation. One of the most advanced ways to integrate probability in projects is the Monte Carlo simulation. This technique uses computational modeling to simulate thousands of possible project outcomes by varying key parameters, such as task durations, costs, or resource availability, based on probability distributions. For instance, instead of estimating that a project will take 180 days, a Monte Carlo analysis might reveal 10% chance of completion in 160 days, 50% chance in 180 days, 90% chance in 210 days. This empowers decision makers to make confidence-based commitments, like targeting a P80 schedule, meaning 80% confidence of on-time delivery. Probabilistic scheduling. Moving beyond the illusion of certainty. Traditional Gantt charts and schedules often assume fixed durations, but real-world tasks fluctuate. To address this, probabilistic scheduling models use three-point estimation. Optimistic, O, best-case scenario, everything goes smoothly, most likely; M, realistic expectation; pessimistic, P, worst-case scenario, delays or rework, using the PERT formula. Expected duration is sum of optimistic, 4 times most likely, and pessimistic, divided by 6. This statistical average smooths out uncertainties and yields more realistic timelines, helping project managers establish credible baselines that withstand volatility. Bayesian probability and continuous learning projects evolve, and so should the probabilities that guide them. Bayesian probability provides a framework for updating risk likelihoods as new data arrives. Example. Initially, there's a 20% probability that a vendor delay will affect delivery. After the vendor misses 2 minor milestones, new evidence increases that probability to 60%. This adaptive approach ensures that risk registers remain dynamic, reflecting reality rather than outdated assumptions, a core principle in agile and adaptive project methodologies. Decision trees and expected monetary value, EMV. Probability is not only about forecasting, it's about decision-making under uncertainty. Decision trees help visualize possible choices, associated probabilities, and outcomes. Each branch carries an expected monetary value, EMV. EMV equals probability times impact. For example, choosing between two project suppliers. Supplier A, 90% chance of success, cost equals $500,000. Supplier B, 60% chance of success, cost equals $350,000. By calculating EMV, project leaders can choose the statistically superior option, balancing cost and reliability through evidence, not instinct. Probability in quality and resource management. In quality management, probability models forecast defect rates or rework chances. In resource management, they help estimate workforce availability or fatigue impact. By assigning probabilities to resource risks, e.g., illness, turnover, competing projects, project managers can proactively allocate buffers or contingency staff, preventing bottlenecks and burnout. Portfolio-level probabilities. Managing uncertainty at scale. When managing multiple projects, portfolio managers must distribute resources and budgets across varying risk profiles. For instance, they might assign 70% probability of on-time completion to infrastructure projects, 40% to R&D initiatives, 90% to internal process automation. These probability scores enable strategic diversification, balancing risk and innovation, similar to an investment portfolio. Common pitfalls in using probability. While probability analysis enhances decision quality, it's prone to human biases. Overconfidence bias. Overestimating accuracy of estimates. Anchoring bias. Clinging to early assumptions even after new data emerges. Optimism bias. Ignoring worst-case outcomes. Skilled project managers combine probabilistic data with experience, context, and continuous review to avoid being misled by numbers. Real-world example. Aerospace project. Scheduling. The aerospace project that beat the odds. It was 7:30 a.m. on a Monday at Astra Tech Aerospace, and the war room was already buzzing. Dozens of engineers, planners, and analysts gathered around a digital Gantt chart projected on a massive screen. The countdown clock showed T-68 days until the scheduled satellite launch, a $200 million project that had zero tolerance for delay. The integration phase was proving to be the critical bottleneck. Officially, the plan stated 30 days for completion. But the project manager, Elena Vazquez, wasn't convinced. She had seen too many projects suffer because of perfect world estimates that ignored the unpredictable realities of space engineering, supplier delays, test failures, or sudden design revisions. So instead of accepting the fixed estimate, Elena turned to probability-based modeling. She gathered her leads, propulsion, electronics, and systems integration, and asked them for 3 estimates. Optimistic, if everything went smoothly, 25 days. Most likely, with normal workflow, 30 days. Pessimistic, accounting for possible rework, 45 days. The data was fed into a Monte Carlo simulation that ran 10,000 possible project timelines. The results stunned the team. The probability of completing integration in exactly 30 days? Only 35%. The 80% confidence point, the P80, was 33 days. Armed with this insight, Elena adjusted the master schedule, added a 3-day contingency buffer, and informed stakeholders with full transparency. We have an 80% confidence of meeting the integration milestone by day 33. If we hit it earlier, that's a win. If not, we're protected. Fast forward a month. Minor supply chain disruptions and an unexpected software recalibration caused small hiccups. But thanks to the contingency, the integration phase closed exactly on day 33, right on the probabilistic forecast. The result? The satellite was delivered to the launch site on time, saving Astra Tech millions in penalty clauses and earning Elena a reputation as the project manager who beat the odds. In post-project review, senior leadership credited probability-driven planning as the single biggest factor in avoiding a catastrophic delay. What began as a simple statistical exercise became a real-world demonstration of how probability transforms uncertainty into confidence. Integrating probability into modern PM tools, modern project management software such as Primavera Risk Analysis, At Risk, or Oracle Crystal Ball integrate probabilistic models directly into scheduling and cost estimation. They allow real-time visualization of confidence levels and risk exposure, a critical capability for high-stakes industries like construction, finance, and aerospace. The future. AI and predictive probability artificial intelligence is revolutionizing how probability is used in project management. AI-driven systems analyze historical data, performance trends, and contextual signals to predict risk probabilities with incredible precision. Soon, we'll see self-learning PM dashboards that dynamically adjust project probabilities as work progresses, turning uncertainty into actionable intelligence. Key lessons for project leaders: probability isn't about predicting the future, it's about preparing for it. A probabilistic approach ensures realistic expectations and strategic resilience. Combine probability with qualitative judgment for balanced decisions. The goal isn't to eliminate uncertainty but to manage it intelligently. Call to action: start your next project by mapping probabilities, not certainties. Quantify your risks, simulate your outcomes, and communicate in probabilities rather than absolutes. The more you embrace probabilistic thinking, the better you'll navigate the stormy seas of modern project delivery. Because in project management, mastery doesn't mean predicting the future, it means being ready for any version of it.